So we move now to question 5. Okay. Question 5. Okay. So we move on, question 5. A bag contains 20 chocolates. So we've got 20 chocolates. Okay, then what else? 15.
Excuse me, sir. Taking you back.
Pardon?
Taking you back. I wanted us to go back to question 4.
Oh, that one is logged out already. It's logged out. So this is a new Zoom meeting.
As in, what did you do to the probabilities that 1 by 8? Did you add or multiply?
Okay. Let me get back to you after this question, eh? Before we end. Then we can get back to that question. Yes. Then we have 12. Peppermint. Okay, those are the sweets that we have. Now the sample space has total number of sweets. So the sample space has number of sweets, the sample space AC has number of sweets, which is 20 plus 15 plus 12, and this gives us 47, 49, meaning the number of elements in the sample space is 47. Now, to answer, we can answer the following questions by drawing a tree diagram. A tree diagram may be very much helpful. So draw a tree diagram. Now, I don't think my space will be enough, so let's try. Okay. Okay, so we're trying to come up with a tree diagram. So there are a few types of sweets. No wonder we're showing 3 trees here. Okay. Then we have some tree here. Also have some tree there. Then we have a tree there. Then we have some tree here. Then we also have some 3 there. Then we have the last one here. So that you have the 3 there, the 3 here, and the 3 there. Okay. So this is our tree diagram. So what are we discussing? We have the chocolate sweets, then we have the toffee sweets, then we have the peppermint sweets. So we can put those letters. C, G, B, C, G, B, C, G, B, G, B, C, G, P, C, T, P. Okay. We are writing the type of sweets to each stem of the tree diagram. C, T, P, C, T, P. Okay, we are done now. So the probabilities, we can now write the probabilities. So we've got 20 chocolates out of 47. So we got 20 out of 47. Is this color okay? The green? Able to see it here?
No.
Okay, let's try to change the color and put 20 out of 47. Then we have toffees, there are 15. 15 over 47. Then we have 12 over 47. So what happens here at the second peak, meaning we're picking, we now have 19 out of 46. There we have now 18 out of 45. Okay. Then the same also happens down here. At this point, we've got 11 out of 6. Here we've got now 10. 10 out of 45 for the peppermint. Then we fill in elsewhere now. So here at T for the second peak, we have 15 out of 46. Then we'll get 12 out of 46. Okay. Then we come here. We've got 15 out of 45. Then we've got 12 out of 45. Then here it's 19 out of 45. Okay. Then there we've got 14 out of 45. Let's write the number. The space is not enough. Then we've got 12 out of 45. Maybe if I can write this number. Let me spell it there, 14 out of 45. Okay. So we can fill in everywhere else. using this format. So here we have 20 out of 46, 15 out of 46. Here, got 20 out of 46. Of course, this is C, this is T, this is P. Okay. Then we've got 14 out of 46. Here we've got 12 out of 46. So you can fill in everywhere else using the same pattern. Now, what do we have in the sample space? The sample space has at this stage, we have C, isn't it? So we get C, then next will be CC, okay, CCT, so we have this CCT, then the next one will be CCP, so we have CCP, then after that, we now go to the next step, CCC, isn't it? So we have C, then we come to this. Sorry, we have C, we have C, then we come to this C. We want to deal with this tree diagram here. We want to deal with this.
Is it not going so
C, isn't it?
Yes.
C, then
CTC.
Okay. So we have CCTN. Yeah, that's what we expect to get. We are done with the first three, right? Of which the last one is in. The last one is CCPN. So what will follow will be C followed by what? T, isn't it?
ETC.
CTCN. CTC. So we have CTC as one that will follow next, isn't it? Has it made sense there? So we are saying that it's C, we are done with CC and whatever, because if we are to go to C again, it means the last one is P, which is already done. So it means we have dealt with this two diagram already. So the next one is this. So to be C, T, C. Then we have C, T, T. At the next, so we have C, T, C, T, T. Okay. After this, then we have C, T, P, N. So we write C, T, P. Okay. We are done with this branch. Then we go to the other branch. We go to this branch now. For this branch, we have C, P, CP what? CP?
CPC.
Okay. So we get CP, son? get C, P, Cn. Wonderful. That is C, P, C. Then C, P, T. Then C, P, I don't know. There must be a wrong letter here, isn't it? That total is supposed to be what? It's supposed to be P, so you can correct it. So we're done with C, P, C. So the next will be C, P, T. So C, P, T, then C, P, P, N. So it means we are done with this branch. We now come to this. So many branches here. Okay. So move on. The next will be T, C, Cn. Okay.
Yes.
So we have T, C, then followed by T what? T,
TCT.
T, then TC,
P. TCP.
TCP. Okay, let's follow up. TCPN. Okay.
Yes.
TCP. Okay. So now we'll go to the next. Are we done with this stage here? We have T, C, which is this part, then T,
CD.
so TC, T, okay, then T, CP, we are done. So we'll go to T what? TT, CN.
Yeah.
T.
Yes.
Okay, so we'll go to T, C, then T, T again.
TT. Yes. Triple T.
Then T,
TP.
TP. So you finish for all. I think
Yes.
my electronic board is small. So you can refer to the solution that I sent to you and finish for all. Then we will start answering the question now. So we now answer the question. Okay. We want to get a probability that all are different. So probability that all are different. All are different. So this will be equal to, we just go for where these guys are different. Completely different. Meaning where we have 3 different letters on the sample space. This is our sample space, right? So we just go to points where you have 3 different letters when you finish the tree diagram. So you observe that you're going to have CGP plus CPT plus GCP plus GPC and plus PTC. So those probabilities are the ones that will give you the required answer. And these are products, isn't it? These are products. It means you have 20 over 47 times 15 over 6 times 12 over 5. Then you go to plus now. Then you start again the other code. 20 over 40 over 47 times 12 over 45 times 15 over 45 means you're done with this. Then you go to plus. You now go to the next. It is 15 over 47 times 20 over 6 times 12 over 45. Then you go to the next. 15 over 47 times 12 over 6 times 20 over 45, then plus 12 over 7 times 20 over 6 times 15 over 45. So until they have that number, 1, 2, okay, there's supposed to be 2 there. 1, 2, 1, 2, 3, 4, 5. Well, 5 products. 1, 2, 3, 4, 5. Okay. So when we conclude here now, we simplify those products. You should be able to get something similar to this. 81 as the probability. Okay, so we can go to the next slide and get to the next probability. Or chocolates. Or chocolate. B will be that or chocolate or chocolate. This is even much simpler, isn't it? Because it's just the C only. Chocolate, chocolate, chocolate. So this gives us C, which gives us from the tree diagram, we have 20 over 47 times 19 over 46 times 18 over 45. And this, when you simplify, you get 76 over that. Then the other one, C, all same. So a bit of getting all that are same, meaning you're talking of CC, TT, PP. So you have CC plus TT plus PP. This is where we have all the same, isn't it? Okay, so we put in the probabilities. The first one is already, the CC is already found, it is 76. 76, that product has already been found. Then plus, we go now to T. The TTs, they are 15 over 7 times 14 over 6 times 13 over 45. Then plus, we go to the other one, the last one, 12 over 47 times 11 over 46 times 10 over 45. So which one is simplified, you must be able to get it, to get this number here as a probability. And then all toffees or peppermint, it's a combination of the two. This is now D, or all toffees or peppermint. meaning that you have TT, or it means addition, isn't it? Plus the peppermint, the PP. So when you get those probabilities from the tree diagram, you must be able to have, you have 15 over 47 times 14 over 46 times 13 over 45, then plus 17 over 46 times, oh, it's not 17, it's just to be 12, right? Okay, 12 over 47 times 11 over 46 times 10 over 45. This must be able to give you 45 over 1080. So we have answered your question. So, so we can now move to the other question.
Sir,
Yes, please.
I have a question.
Okay.
When coming up with the tree diagram, like for example, maybe we've got like T, PP,
Okay.
like on a branch, like that. For the T, since they are coming from T, yeah, they're coming from branch T. So the PP, does the third branch, the one having P, will it be reduced by 1, or you just have to put this the same number you are given?
It has to be
question.
reduced. It has to reduce by 1
Okay.
on numerator and denominator.
On both?
Yeah, on both, since it is the second P.
Oh, okay.
Yeah. Okay. So we proceed now. We go to the next question. The next question . Next slide. Question is 6. A bike contains 30 children. A class contains 30 children. Okay, so question 6. Question 6. A class contains, so meaning that the sample space, the number of elements in the sample space, I don't know whether those are screenshots making noise. Okay, so the total number of elements in the sample space is 30, according to the question. And then we're told that we have 18 girls, 3 denoting girls is 18. And then B denoting boys. Okay, I'll be timed out in the next few minutes. Then, since this is a new question, we may not finish it in the few minutes or as quickly as possible. Okay, let's try. Let's try to finish it. This is representing boys, and there are many? 12, isn't it? Okay, what's the question now? 4 complement theaters tickets distributed at random to the children. Find the probability that all the tickets go to girls. all the tickets go to girls. One maybe think of using a tree diagram and say, we have this tree diagram, we have girls, we have boys. Now, since all the tickets are going to girls, we have this situation, girls, boys. All the tickets are going to girls. Eh? So we have this is the situation that we have, and so we can put the number. Girls are how many? Girls are 18 out of 30. So meaning at the next stem, we're going to have 17 out of what? 29, isn't it? 29, then we're going to have 16 out of 28. Then the last one will be 15 out of 27. So probability that this goes to girls will be probability that the tickets go to girls or go to girls will be equal to simply GG, which is equal to 18 over 30 times 17 over 29 times 16 over 28 times 15 over 27. So when we do that, what does the product give us? The product gives us 6.8 over 609. So this is a probability. But now there's a situation when we may have a lot of these. For situation where you may have a lot of these, you may use some simple method. This is just a combination, isn't it? So one may use, one may use the combination, meaning out of 18 girls, we are choosing, out of 18, we are choosing 4, for which you give tickets. Eh? So this gives us the total being chosen, divided by the total number of students, which is simply 30, choose 4. This is a combination, remember the binomial. So this gives us the required probability, or go to girls. Okay, so this is the probability, which gives us 6.8 over 609. So let us rejoin again for the next question, unless there are questions on this one. Any question with this? Okay, since there are no questions,